Let's look at the next one on this page. List these metals in order of increasing ease of oxidation if the following reactions occur spontaneously. We didn't talk about that. We didn't talk about ease of oxidation. We didn't talk about spontaneous. Yeah, we did. I don't think I used the word spontaneous. What does spontaneous mean? Instantly, without intervention. Okay? When my kids were at home, the family room never got cleaned up spontaneously before bedtime. I had to go in there and provide constant supervision and encouragement. Pick that up now. Right? So it means that it just goes forward. So what kinds of reactions are these? Single replacement, right? So we talked about single replacement in terms of the activity series. And when something is more active, what does that have to do with oxidation? We talked about this, and it's typed in the notes a few pages back. It means that something that is more active is cutting in, so it's actually losing electrons, not taking electrons. It's actually losing electrons. So something that starts off as the metal and cuts in on the compound is becoming a metal ion, so it is getting oxidized. So we talked about that things that are active are getting oxidized. So now with that in mind, what information does this equation tell you about the relative reactivity and oxidation ease of these two materials? Which one of these things, we're only looking at the first equation, is more active? Pu. So the first equation tells me Pu is more active than Tl. What information does the second equation give me? Ru more active than Pu. And what does the third equation tell me? Ru is more active than Tl. Use that information to now put them in order. Who is most active? Ru is most active. Who's next? And who's last? Now, if we think about this, who is the easiest to oxidize? Ru, because it's the most active and it gets oxidized. So, order of increasing ease of oxidation. So, easiest, hardest. So, what order do they go in? Who goes first for hardest? Tl, Pu, Ru. Is that hard? Haven't we talked about activity and we defined it saying that when something's more active, it's getting oxidized? We did. And if you don't remember that, look back to your note packet on page 5-10. On page 5-10, it says right here, the more active element is getting oxidized. So when you do that, then I think it makes sense to be able to answer those questions. Oh, you haven't memorized that yet? Yeah, it's printed on the test. Don't memorize that. And you also don't memorize the giant charts that are coming in chapter 6. Okay, you don't memorize that stuff. You read the chart. Well, if we read the chart, why do we have to memorize the solubility rules? That's different.